I'm going to go over some velocity problems with you. Remember I told you the other day, velocity is just speed with a direction. So it's the very same formula for speed. So velocity is distance over time. Now, give you a little hint right here. Anytime you have a three-part equation like velocity is distance over time or whatever, you could put it into this little pyramid. And if you do this, you don't have to rearrange the equation to solve for one thing. So I said that velocity is distance over time. So we know that distance is over time. So velocity is distance over time. If you're solving for time, that will be distance over velocity. If you're solving for distance, it will be velocity times time. So you can just use it like that. Now, if this confuses you, it's fine to just solve it and work it out. Solve for whatever you're looking for. But that's just an easy way for me to look at it and not have to rearrange the equation. All right, so number one says, suppose the polar bear was running on land instead of swimming. If the polar bear runs at a speed of about 8.3 meters per second, how far will it travel in 10 hours? So we're looking for how far. That tells us we're looking for distance. Distance is velocity times time. So distance is velocity times time. So we're just going to put these in here. The velocity is 8.3 meters per second. The time is 10 hours, but our velocity is in seconds. So the first thing we have to do is change hours into seconds, okay? So the first thing we're gonna do, we're gonna change 10 hours into minutes by multiplying it by 60, because there's 60 minutes in an hour. So that means that it will be 600 minutes. And now we're gonna change minutes into seconds. There's 60 seconds in 1 minute, so that will come out to be 36,000 seconds. All right, so we're going to multiply that so we're going to take 8.3 times 36,000. That's going to give us 298,800 meters. The next one, like the polar bear, the walrus is a strong swimmer. Although it does not have the same endurance for short periods of time, a walrus can swim at an average speed of 9.7 meters per second. How far would a walrus swim at this speed in 3.4 minutes? So we're looking for how far. So distance is velocity times time. So the velocity was 9.7 meters per second. The time is 3.4 minutes, so we're going to multiply this by 60 to get it into seconds. So 3.4 times 60 is 204. So 9.7 times 204 is 1978.8. Okay, and that's going to be meters because it was meters per second and this was seconds. So seconds mark out and that leaves you with meters. If it asks for kilometers, all you're going to do is move the decimal over 3 to the left, so that would be 1.9788 kilometers. Same thing up here. If it asks for kilometers, you would move it over 1, 2, 3 to the left, so that would be 298.8 kilometers. Okay. All right, the next one, the maximum posted speed limit on the U.S. interstate highway system is found in rural areas of several western states. This maximum speed is 75 miles per hour or 121 kilometers per hour. What is the distance in kilometers that a car travels if it moves continuously at this speed for 3 hours and 20 minutes? So it's wanting distance So we know that already that distance is going to be equal to, if we draw a little pyramid back over here, we've got velocity is distance over time. So distance is velocity times time. So the velocity, we've already said, was 121 kilometers per hour. I'm using the kilometer one because that's usually what we use in science, is the metric system. And then we've got 3 hours and 20 minutes. So what we're going to have to do is convert this 20 minutes into hours. So we're going to take 20 divided by 60, and that will give us 0.333. So that'll be 3.333. All right, so we're going to take that times 3.33. So that will be 402.93 kilometers. All right, the next one. For normal situations, the minimum speed limit throughout the U.S. interstate highway system is 45 miles per hour or 72 kilometers per hour. How far in kilometers? So it's asking for distance. In kilometers will a car travel if it moves continuously at this speed for 3 hours and 20 minutes? So the 3 hours and 20 minutes is going to be the same as up here, so we already know that that's 3.33 hours. We're using the kilometers per hour speed because it asks for kilometers. So distance is velocity times time. So the velocity is 72 kilometers per hour. And the time is 3.33 hours. So we're going to multiply those together. So 72 times 3.33 is 239.76 kilometers because the hours will mark out. Okay, so let's move on to the next ones. They say various types of tree sloths share the honor of being the slowest moving mammals. An average tree sloth moves at a speed of 0.743 meters per second. How long does it take a sloth moving at this speed to travel 22.3 meters? So it's asking for how long. So we're solving for time. If we look up here, time is going to be distance over velocity. So time is distance divided by velocity. So we said the distance is 22.3 meters. The velocity, it moves at a speed, remember speed and velocity are interchangeable, of 0.743 meters per second. So we're going to take 22.3 and divide it by 0.743. That's going to give us 30.01 meters are going to mark out. And that's going to leave us with seconds. All right, the next one. The longest stretch of straight railroad track lies across the desolate Nullarbor Plain between Australian cities of Adelaide and Perth. The tracks extend a distance of 478 kilometers without a curve. How long would it take a train moving at a constant speed of 97 kilometers per hour to travel the length of the track? So it's asking for how long, so we're solving for time. Time is distance divided by velocity. So the distance is 478 kilometers. The velocity is 97 kilometers per hour. So we're going to divide 478 by 97. And that is going to, the kilometers will mark out. That leaves you with hours. That's going to give us 4.93 hours. the next one. The Concorde is the fastest supersonic passenger jet. How long would the Concorde take to travel 6,265 kilometers between New York City and London, assuming that the jet travels at a maximum speed of 2.15 times 10 to the third kilometers per hour during the entire trip? So it's asking for how long, that's time. We already know that time is distance over velocity. So he said the distance was 6,265 kilometers. We're going to divide that by the velocity or the speed, which is 2.15 times 10 to the third kilometers per hour. All right, so if you have a scientific calculator like this one, we're going to do 6.265 divided by, we're going to put this in parentheses, 2.15 times 10. You do this little raised button right here to the third, and that will give you 0.0029. The kilometers mark out, and that leaves you with hours. All right, the next one, number 8, the longest distance in a track and field event is the 10-kilometer run. The record holder for the women's 10-kilometer run is Wang Junxia of China. Assuming that she ran 10 kilometers at an average speed of 5.644 meters per second, what was her time? So we're looking for time. Time is distance over velocity. So the distance is 10 kilometers. The velocity is meters per second. So we're gonna have to change this kilometers into meters. That means we're gonna move the decimal over 3 to the right. So instead of it being 10 kilometers, if we move it over 3 to the right, we're gonna add 3 zeros behind it. So it'll be 10, 1, 2, 3 meters, so 10,000 meters, divided by 5.644 meters per second. Alright, so we're gonna take 10,000 and divide that by 5.644. That's gonna give us 1,771.8. The meters are gonna mark out, that leaves us with seconds. Okay, we move on to the next one. Cheetah, the fastest of the land animals, can run 274 meters in 8.65 seconds at its top speed. What is the cheetah's top speed? So we're looking for speed, so we're just looking for velocity. So that formula is distance over time. So the distance is 274. And we're going to divide that by the time, which is 8.65. So 274. 8.65 gives us 31.68. That's meters per second. Okay, the next one. In 1985, Matt Biondi set a record for the men's 100-meter freestyle event. In swimming, he took 49.17 seconds to swim the 50-meter length of the pool and swim back. Assume that half of Biondi's record time was spent traveling the length of the pool. What is his speed? So we're looking for speed. Velocity is distance over time. Okay, so the distance is a 50-meter length pool, and the time is 49.17 seconds. All right, so we're gonna take the distance, which is 50 meters, and divide it by the 49.17 seconds. So that should be roughly 1. So 50 divided by 49.17 is 1.02 meters per second. And so that was for a 50-meter length, but that was going back and forth. So that's for half of it. So we're going to multiply this by 2 because it's a 100-meter freestyle. So we're going to have to divide it or multiply it by 2. So that will give us 2.04 because this was only for 50 meters length and it was asking for a 100-meter length. So we're going to multiply it by 2 and that will give us 2.04 meters per second. All right, so the next one. The fastest crossing of the Atlantic Ocean by an ocean liner was made on July 7th, 1952. The ship, the SS United States, traveled 4,727 kilometers east by northwest in 3 days, 10 hours, and 40 minutes. It seemed that the ship had traveled the same speed but directly east. What would the velocity of the SS United States be in kilometers per hour? All right, so we're looking for speed or velocity. So we know that velocity is distance over time. So the distance is 4,727 kilometers. The time, it wants it in, remember it said kilometers per hour. So we're going to have to convert all these to hours. So we're going to take the 3 days and convert it into hours. So that'll be 3 times 24, which is going to give us 72 hours. And then we're going to convert those 40 minutes to hours by dividing it by 60. So 40 divided by 60 is 0.67 hours. And then we're going to add the 10 hours to that. So 72 plus 10 is 82 plus the 0.67. So it's 82.67 hours. So now we're going to take the 4,727 and divide it by 82.67. 57.18 kilometers per hour. Okay, the last one for these, the bird that migrates the farthest is the Arctic tern. Each year the Arctic tern travels 32,000 kilometers between the Arctic Ocean and the continent of Antarctica. Most of the migration takes place within 2 4-month periods each year. Assume that an Arctic tern completes the second half of its annual migration distance in 122 days. Also assume that during this time the tern flies directly north. If the tern flies the same distance each day, what is its velocity in kilometers per day? Okay, so we're going to look at this one. It's wanting to know the velocity in kilometers per day. Okay, so we know we got 122 days. And then we've got 32,000 kilometers. So velocity is distance over time. So the distance is 32,000 kilometers. The time is 122 days. So we're going to take 32,000 and divide it by 122. And that will give us 262.3 kilometers per day. Okay, so that was for the whole thing, but it's talking about half of its annual migration for this. So we're going to divide, let's see, we divide we divide this by 2, that will give us for half of it. So the answer will be 131.15 kilometers per day for half of the trip. That's a little more difficult with that one, but you can see what it's kind of getting at with that one. All right, so what you're gonna do now is you're gonna solve the mixed practice on your own. Okay, so if we look at this one says a typical snail doesn't cover very much ground even when it's moving at its maximum speed of 5.0 times 10 to the negative second meters per hour. How far will the snail travel? So it's asking how far you're gonna solve for distance in this one. And remember, if we go back to the little pyramid thing that we've drawn, remember velocity is distance over time. So that means that distance is velocity times time. So you're going to solve for that. We're going to skip over number 14 because it's just got a lot to it and it's kind of difficult. So you're not going to see anything like that on your test. This one is asking how long. So that's asking for time. So if we look at this, time is distance over velocity. So you're going to solve for that. Do pay attention. This one is in kilometers and this is in meters per second. So you're going to have to change this. And you should have learned a little conversion factor. You should have been using this for a while, but KHDUDCM. So this is the metric conversion thing, and that's why I'm moving this over. These are your base units. So this is meters, grams, or liters. Okay, so we're dealing with meters here. So if you're going from kilometers to meters, your decimal would be here right after it. So you move it over 1, 2, 3 to the right. So in this, you would move it over 1, 2, 3 to the right. So it would be 3,790 meters. Okay, just make sure that you're paying attention that your units line up. This one is asking how far, so that's distance. So to solve for distance, it's velocity times time. Okay, this is meters per second. This is in minutes, so remember you're gonna have to multiply this by 60 to get it into seconds. And then the last ones, this one is asking what is the speed? So speed or velocity is distance over time. So it's giving you how much it grows. So that would be the distance, and the time is 365 days. But it's wanting it in kilometers per hour. First thing you're gonna have to do is change that 1 centimeter. We've got the KHDUDCM. So it's centimeters into kilometers. So the decimal would be here. So you're gonna move it over 1, 2, 3, 4, 5 to the left. So if it's 1 centimeter, you're gonna move it over 1, 2, 3, 4, 5 to the left. So you're gonna fill these in with zeros. So it'll be 0.00001. That will be kilometers now. Okay, and this one is in days, but it's wanting hours. So to change days to hours, you're gonna have to divide it by 24. So 365 divided by 20. Wait, times it by hours, sorry. I don't know how I said divide. 365 times 24 will give you 8,760 hours. Okay, so now you can solve that one. Then 18 is talking about the Trans-Siberian Railroad. If you were to leave Moscow and travel on the railroad at an average speed of 90 kilometers per hour, how long would it take? So how long is the time. So remember that time is distance over velocity. And so the distance it gave you is the 9,354 kilometers. The velocity is in kilometers per hour. There's no conversions for that one, so you just plug in and solve. This one's asking how long. So once again, that's time. Time is distance over velocity. So your distance is 5,530 kilometers. Your velocity is 45 kilometers per hour. There's no converting. The units are the same. So you plug that in and solve. And then the last one, it's asking you how far. So you're solving for distance. Okay, so distance is velocity times time. Gave you the velocity, kilometers per second, but the time is in years. So you're gonna have to convert that years to seconds. So 2,590 years. Okay, so first thing we're gonna have to do is convert years into days. So 2,590 times 365 days in a year is going to give us 945,350. So 945,350 days. Now we're going to convert days into hours. So there's 24 hours in a day. So we're going to take that times 24. That will give us 2268840 hours. So you can see that that's getting a little bit long. All right, so now, and I've already got this in my calculator, so I'm just leaving it like that. So I've got it in hours. Now we're gonna have to change hours into seconds. So we're gonna take that, hours into minutes, I mean. So we're gonna multiply it by 60, that number by 60, to get it into minutes, because there's 60 minutes in an hour. That's 136130400 minutes now. And now we're gonna do minutes into seconds, so we're gonna multiply that number by 60. And finally, it's in scientific notation. So that will give us 8.16 or 17 times 10 to the 10th. That E10 says that it's times 10 to the 10th. That's in scientific notation. So that's how many seconds this will be. So that is the number that you're going to plug into your time, and you've already got your velocity. So then you can solve for that. So you are going to have to solve the mixed practice on your own. I've worked out examples of all the others. So you will start with number 13. We're not doing 14. So you do 13, 15, 16, 17, 18, 19, and 20 on your